happy with you as a design engineer or a mechanical design engineer or a draftsman or whatever you are playing a role in that company or as a freelancer or whatever your job you are doing. So now let's move to the freedom to make design changes. So that is the freedom that I am just explaining. The main topic is, so where you get that freedom. You can see we have 100% freedom at initial stage, but at that stage we don't have enough knowledge. So we will just make a like we will capture a second and first block from that graph, and this these two blocks would be the area where actually you will apply DFMA in the design process. You cannot apply that after zero point 0.6 line. You cannot apply that just before that zero point 0.6 line. It would be the best choice to use that before, in between zero point 0.0 to zero point 0.2, or you can just go beyond that zero point 0.2, or just go beyond zero point 0.2, or you can 0.23, 0.24. So basically, if you get that point, then I think you have completed your 80% of knowledge about DFMA. So now let's talk about what are the benefits of DFMA. So it will reduce manufacturing costs, right? It shortens development cycles. It helps teams. So what cycles I am talking about? So if some of you guys have any experience from the industry, from the manufacturing, from the some of you guys, if have ever have get chance to visit an industry, you will see there is a floor manager that actively runs on the floor and say, hey, what are you doing? Hey, what are you doing? So there are actually the development cycles. So you have to take care of that development cycles, and this DFMA can actually make that development cycle shortens. So automatically it is also connected to somewhere to the cost reduction. And it also helps team work better together by aligning goals, and it improves the product serviceability and maintenance. When everyone on the team, from the engineering to manufacturing or marketing, understand the product better, collaboration becomes smoother. So how I will add here a point, how you can get best results to apply that DFMA in your design process. So the best choice is to communicate to your fabrication engineer, whether it is a technician, it is a machinist, it is a operator. So never ever hesitate to ask, like, how you are doing. Just go just go there. If you can't go there, you can ask to floor manager, like, hey sir, just tell me what are the machines do we have in our floor, so I can understand better. So always try to make your communication strong with the floor persons. All right. So what designers should know? So this is the point that I already have mentioned you guys. So a designer should actually know about the manufacturing methods like machining, how that part would be machined, what machines do we have in our floor, that either it is a single head, three head, four head, either it is a two axis, three axis, four axis, five axis, whatever the machine do we have. And other thing is assembly process. So you have to check that what assembly procedures you guys are actually doing in your floor, and tolerances, materials, joining techniques. This joining technique is also actually it is directly related to the fabrication. So let's see an overview of that, and a simple view of DFMA process. We begin with concept design, and actually this concept design is not only these words as a concept design. In that concept design phase, you have to cover most of the steps that are used in actually designing a machine or a machine part, and that is a book named as Machine Design, and that is basically for mechanical engineers. In that phase you actually get that uh, what is what part you are going to make and what test you have to do on that part, what requirements do you need from that part, whether it is a rotational part, it is a linear motion part. So everything would be in that concept design. So the second phase is DFA, and the third phase is DFM, and the last phase is detailed drawings. And maybe most of you guys are well aware of that thing, that after creating a 3D model, you guys just send detailed drawings to your client as a freelancer, as a design engineer, if you are a floor manager, whatever you task doing. So let's just focus on DFA principles. So design for assembly, here are some basic principles. Keep the part count low, fewer parts, fewer chances for error. Use self-locating parts, so no one has to guess how it fits. Design parts that are easy to handle, especially with gloves or tools. Avoid anything that needs adjusting on the assembly line. Following these guidelines can drastically reduce time and training needed on the shop floor. So here in design for assembly, we actually have some subcategories that includes manual assembly, that is common for small or custom batches. The other one is automated assembly where machines do the work. And the third one is robotic assembly where especially for precision or repetitive tasks. So each method has unique requirements. For example, robots prefer symmetrical parts with clear orientation. Knowing this during design helps avoid costly redesigns later. I hope you guys are getting my points. So let's move on to our 3D model that I just have created to show you guys. Let me share my other screen. Be there. Just give me a thumbs up if you can see my screen of the SolidWorks. All right. Thank you guys. So here we have a 3D model. Actually, this is I just created that to show you guys what DFMA actually do. All right. So this is not a functional part. This is not a machine part. Like it is just a ideal part. So what do you think? Like how we can reduce number of assemblies, the number of parts, number of processes in that assembly. So our main concern is let's count that how many parts do we have in that assembly. So for that, this is my macro that I have created. Actually, these are my different macros that I have created by myself with some codings. So let's click on that and you will see that you have only 8 parts here, and that is, and unique parts are also 8 here. So if I can show you guys the optimized design, that is actually the optimized design. And now if we can, yes, Zishan, you have something, I guess, by sheet metal or surface weldments or reducing nails. Yeah, exactly. Sorry, I haven't read that messages. So let's count that assembly, how many parts. Now it is just 2 parts. So what we have before that, it were 8 parts, right? And now we just have 2 parts. So actually reducing the parts, you are also reducing the processes that has to be done on each part to make that assembly or your product or whatever the machine, the switchboard or whatever the thing you are going to create. So no, this is just a simply sheet metal part. I have, instead of making that assembly, like if you can show you guys again the like this assembly. Here you can see we have I have a separate base frame, and then I have two different flanges as a separate assembly, and then we have bolts here like one, two, three, four. So instead of doing that practice, always try to suggest your customer, your company, that uh, that why do we need that much parts. So if we can actually reduce that parts, we can actually reduce the cost. So your company, your client would be very much happy with you guys. I can bet that. So if you can, so in our optimized design, as you can see, we just have two parts. One part I have created a sheet metal parts, and I have attached that edge flanged instead of making that assembly. And now let me share you guys again to our presentation. All right, guys. So if you can see my screen, kindly give me a thumbs up. All right, thank you. So now let's move. So now we have checked that how design for assembly can actually affect our cost. It how it actually affect our number of parts in any assembly. So moving forward, let's see, next topic is we have design for manufacturing, and it is actually a critical part. So in design for assembly, you just have to check what are the processes you are doing and how many parts you are going to make. But in that phase, like design for manufacturing, you have to check every single detail in your flow, like which machine, what are machine tolerances, what are their limitations, like do we have two axis machines, three axis machines, four axis machines, do we have manual machines, do we have robots in our machines, or do do we just making our parts with a person use machine. So I think you are getting my points. All right, so let's move on to this. So, what are the benefits of DF? As DFA has its own benefits, similarly, DFM has its own benefits. So, combination of both actually makes our DFMA complete strategy design. So DFM gives us several benefits. So some of them are I have mentioned here. So it lowers material and tooling cost. It keeps product quality consistent, and it makes it easier to ramp up production when demand grows. For example, if your part is designed for injection molding, right, but has undercuts or sharp corners, that could require complex tooling, slowing down your production, and automatically it will increase your cost. So all right, what are the principles of DFMA? It standardized the parts and materials, designed for multi-use tooling, reduced tight tolerances, designed for efficient machining, forming. By following these steps, we can actually reduce surprises during production and reduce cost. So just don't this make these principles or whatever the knowledge I am telling you guys as a theory, as like we just did in our normal university class or normal college class. Just try to make implement that in your real life if you really want to grow as a design engineer or specifically as a mechanical design engineer. I have again mentioned that this is specifically for mechanical design engineers. Now, so let's move to our next model. Let me share my screen. I have created some other assemblies. So, so here is a question here. Engineer Usman Ahmed Siddiqui, sir, how can we design parts ourselves? Actually, that is an interesting question. So actually nobody. I will again say that nobody can teach you how to design a part, right? You have to put your efforts, you have to put your own research, you have to see tutorials. YouTube is your, chat gpt is yours, everything you have. So why we still ask how how would we make a part? So are you getting my point? I am not here to make you guys demotivate. I am just telling you that because I have also experienced that in my initial uh, projects, in my initial uh, experience. So thank you, Usman. If you get my point, you can also reach me out. If you need any help, I will free of cost. I will help you. So whoever wants any help regarding making a part, regarding so whatever the help you need for designing, especially for SolidWorks, you can reach me out. So Zishan asked by Usman, sir, can the optimization be done by a design table DOE method? Yes, you can use design table. Actually, it is just I am just telling you an overview of what DFMA is. All right. So in that DFMA tool, you have to use an other subtools, right? So you can use parametric modeling, you can use macros, you can use design tables, you can use whatever the tool you think it can reduce the designing effort of you guys, designing efforts of designer, or it can reduce the assembly cost, or it can reduce the product cost. So everything depends upon our designer and the standardizations and the quality and the requirement of the customer. All right, so Usman, no problem. So let me show you the other. So can you guys see my screen? So just give me a thumbs up so I can move on to showing you. All right, thank you guys. So I hope no one is sleeping here. So if I can, oops, yeah, here. So now let me show you other part. So here I have an assembly. So actually, this is a prototype of functional part, right? That I was going to make for someone. Okay. So just don't overthink about that. Just think it as your ideal part. So what part do we have in that assembly? So let me make an explode view. So no, can you see that we have a lot of parts, right? Are you getting my point? We have a lot of parts, and if we can measure that, let's click on that count part, and it will show you how many parts we have. We have 11 parts. All right. So now, what do you guys think we can remove from that assembly to reduce our components? So just send me a message in the messages box. Do you have any idea? As you can see my screen, if you can see my screen, here is an assembly. And what do you think we can exclude that to make our assembly according to DFM? So so on which basis we can implement DFM. Number of boards, yeah, exactly. Usman, you are right. Here is the one point. Anyone else? So quick, anyone else have? It depends on the movement and working of the board. All right, you are getting my point, Abdullah. But there is, let me clear that there is no moving part here in that assembly. So anyone else have anything in? Don't hesitate. It is not a quiz. It is not your university quiz. So don't worry. I am not going to give you marks on that basis. I am not going to judge you. Just relax and just tell me if you have any idea. The base only the box is enough. Yes, actually, and that is up ABD Al Aziz. All right, thank you. So you are also correct. So let's go to our optimized design. So here we just have our base part that can be a injection molded, that can be a sheet metal part, that can be a machined part or whatever. So it will depend how I would design that. And then I have a pressure gauge. You can say it is a rough model of pressure gauge, and then so let's just explore that part and let's see what actual parts do. So we have one, two, three, four. So if we can count that, so now we just have four parts. So just imagine that you are creating an assembly and that was 500 parts for your large assemblies. I am talking about large. So in production or in research and in machine designs, you just don't have 3, 4, 11, 10, 15 parts. So when you are designing a machine, it can include more than 500 parts. Like even when you are designing in SolidWorks automatically change their setting to large assembly settings. All right. So just imagine you have, let's say, 400 parts in your assembly, and just doing your research, your R&D using GPT. I am not against the GPT. I am again and again telling you guys use GPT, because if you would not use that, actually he will replace you. GPT is capable of doing 3D models. I am just telling you because I have some experience on that. GPT can actually make 3D models if you can give it a exact prompt for that model, if you can explain that. So you can use GPT, you can use websites, you can actually read books. You have to read books, right? So if you are in a learning path, so you should read books. I'm not a good student. I am not saying that I have too much GPA in my life. I don't have too much GPA in my life. I am just a average student. All right. So, but still, I would suggest that use your books. That will actually help you. So let's say you moving to our point. So let's say you have reduced your parts to from 400 to 200. Unless or until it is a complex V6 engine, just imagine telling GPU to generate engine on time. No, no, Burhan, you are taking it wrong. You know, actually, you can do that. It depends on how you can get. So if you can actually design, so you know the commands, what commands do we use, so you will just tell that GPT, hey, just do that, hey, just do that, hey, just do that, then I need that V6 engine, 6 cylinders. That would be, I need that torque. You can use that GPT for whatever the reason you want. How can we reduce parts in SolidWorks? So SolidWorks don't have any automation that will automatically reduce your parts. So you have to think about that. There is no automation, there is no magic that will automatically reduce your part. So you have to think about that. All right, Isa Muhammad, you're getting my point? Okay, so let's say you have reduced your parts from 400 to 200 parts. So no, just think about that. You are in the industry, or you are doing freelancing work, and after getting that achievement, you are presenting your strategy to your senior or whatever the firm you are working, or your customer. So how would you think they will react to you guys? They will definitely say excellent to you because you are actually reducing their cost. So whenever you can reduce the company cost, production cost, manufacturing cost, whatever the cost, the company will give you a thumbs up. Or the customer, if you are working as a freelancer, the customer will automatically give you a best review, excellent review. You are getting my points, I think. So let's take that question as well. You have used GPT to build equations for the recent DOE method, my FYP. So Usman, actually, when you are doing your FYP, it is good approach. But I will suggest you that once you will get into an industry, so try to get in that industry and try to fit yourself in design engineers or in design field. All right, then then you will automatically make your mind that actually we can do that with GPT or with whatever the other DeepSeek and whatever the AI tools we have. Actually, it is not replacing your job. I am not saying that it can replace you guys. But if you just imagine yourself, you know the keywords, you know the prompts, so and you are a design engineer as well. You know the every command in SolidWorks. You know how a part is made. You know how assembly is made. You know how detailed drawing is made. You know how bill of material is made. You know everything. You are a professional SolidWorks designer, right? So now jump into that GPT. All right, you can take a lot of help from GPT. So in that way, it would it would not cause anybody of me, you, to take our job, right? So and we have Mahindra. Can we automate that using Python code? No, actually, Mahindra, it is a good question. But in SolidWorks, we have VBA. As you can see here, so let me show you that if I can show you. So can you see my screen? Alright, so here is the coding that SolidWorks use, and it is not a Python language, it is not a C++ language, it is actually VBA language that simply use APIs of built-in SolidWorks, or you can make your own APIs. So it depends on whatever the work you are doing. So actually, this macro is very powerful. It can actually cross the boundaries of SolidWorks limitations. All right, so here we have that model. Let me again get to our presentation. Where are you? Here it is. So can you see my screen? All right. So actually, this was our last model, and thank you. To wrap up, DFMA is not just a set of rules, it is a mindset. It helps us design smarter, reduce waste, cut cost, and improve the final product. Thank you for your attention. I would be happy to take your questions now. So Muhammad Burhan has, yeah, yeah. Zishan, can you mute them so we can take answers, we can take questions from that. So here, Fiaz Abdul Aziz, is there any specific books or course you could suggest? So I would suggest you guys that I had already mentioned the machine design book, and you can say the manufacturing book, and the other one is about the tolerances, and I don't remember the exact name of that book. But if you guys need that names, you can directly reach me out. I will definitely tell you what books you need. All right. So Neha Boss, do you have any question? You can send message. You have raised your hands. And Frank, please can you go over the tricks on optimizing product parts so as to reduce cost? So actually, Frank, we can make that in another session. I think if the management thinks we can create another session, we can create. Actually, we can create. I would suggest the management. So if we can create a poll voting on SolidWorks macro or SolidWorks simple design, SolidWorks for beginners, SolidWorks for intermediate, SolidWorks for advanced. So we can actually do that. Oh, a bunch of questions. So the next question is Al Ghifari, is DFMA follows manufacturability such as CNC? Yes, exactly, exactly. It does. Al Ghifari, it does. So Mehreen Farid, which form we have to fill? So I don't have answer for that. Zishan, I think you can answer that question. Which form do we have to fill? All right, so Mehreen, I think you got your answer. And then we have Mahindra. So, sir, could you give roadmap to beginners? Yes, I can definitely give you guys. And I'm again saying you can reach me out through my LinkedIn. So I will tell you from where you have to start and where you can go.